Welcome to today's webinar, the first webinar this year. I wish you at first a Happy New Year. Our webinar today has the topic Consider Construction Stages in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the Dlubal website, press releases, the German and English webinars, etc. My colleagues can introduce themselves.
Yeah, hello. I also wish you a healthy new year. My name is Adrian Langhammer. I'm responsible for customer support and development, and there especially for construction stages and also for concrete design. And I will show you today the example.
Yeah, hello. My name is Stefan Frenzel. I work here at Dlubal in the support and also, of course, in developing the dynamic add-ons. And I will today answer your questions about the construction stages. Yeah, wish you a nice webinar.
Okay, thank you for introduction. Then we can switch off our webcams that the attendees can see the full screen. You can ask questions during the webinar with the panel on the right side of your screen. You can enter a question here and we will answer you. In the case you don't get an answer during the webinar, because there are too many, you will get an email afterwards with the answer. The other way is to watch the entire webinar and then email questions to info@dlubal.com. To the agenda today, at first Adrian will define the construction stages on the model, then in the second step on the load side, then the third point of the webinar is design based on construction stages, and the fourth point is review of results and documentation. And after the presentation, he will at another point, he will introduce some new features in the add-on. Okay, maybe in additional information, we will record the webinar, and you will get an email in the next days where you can find the recording and the link to the models. Maybe at the end of the webinar I will show you where you can find the recording and the models. So then I hand over the screen to Adrian. Then let's go, Adrian.
So you should see my screen now. Yeah.
Yes.
Yeah, first of all, short introduction of the example or the main example I want to show today. This example is based on a literature example from the German book Finite Elemente in der Baustatikpraxis from Rustler and Barth, which is in turn also based on another example from Bischoff and Plätzinger. I did not use the whole structure of the literature example. I only used substructure to show the effects regarding construction stages. The structure, as you see, is already modeled. There short description of the structure. There is shear core with concrete walls with a thickness of 40 centimeter, and there are also slabs. Here I can show it maybe also so. There are slabs with a thickness of 20 centimeter, and there are quite slender columns here with square cross section with 20 centimeters aside. First, before I start with the construction stages, I will calculate the internal forces and the deflection of the whole structure with self-weight without considering the construction stages to show what the topic is in this example, what the problem is in this example. Yeah, if we take a look at the deflections, we see that the slabs here hang on the inner core, and if we take a look at the internal forces, bending moments in the surface, we see, I have here a section in the middle, we see that as higher we get, the moment about the support is increasing and the moment in the field is decreasing. This effect appears due to the different stiffness distribution in the structure and due to the effect that the slabs hang on the core. And in reality, you do not build the whole structure in one step. You will build it in single stories, and the weight is applied not in one moment, so it is step by step applied. And to consider this, we can use the construction stages, and to, of course, to avoid such topics like we see here, that the moments are maybe not correct in the highest story. Yeah, so I will show the input for the construction stages. First of all, you will find the construction stages add-on here in the base data, where you find all the other add-ons. Here on the left side, construction status analysis, or short CSA, and I already activated the add-on, and yeah, and the input is done here in the navigator in two parts. There is one part on the structure side to define the stages on the structure side, and the other part is definition of the stages on the load side. So we will start with the construction side. So I already defined some stages. If there's no stage defined, you can start here with right-click New Construction Stage. And then I defined them already because the input for the stories is quite similar for the whole structure. So I don't want to waste time, and yeah, so therefore I defined already some of the stages. For the input of the construction stages, you have here in the first register the parts or the structural elements which could be used in the construction stages. If you want to use one of the structural elements like members or surfaces, you have to check here, and then you will get an additional register where you have to do the input, or where you have to choose the members or surfaces which should be activated in the particular stage. Yeah, there's another part here on the right side, an input regarding the time-dependent analysis. This is another add-on which is at the moment not ready. It is still under development. In the future, there will be the possibility to consider also the time-dependent analysis together with the construction stages. But as I said, it is at the moment still under development. I guess when it is ready, we will have an additional webinar regarding this topic. So we will show then especially the time-dependent analysis. Today, there's only the yeah, let's say calculation of the internal forces considering the construction stages. So yeah, after I've checked here the members and the surfaces for this construction stages, I have to choose which member, first which member and then which surface should be applied in the stage. So I will start with the member. As I said, I already did some input. Where if there is once a column or a member selected in the stages before, I could not select it again. You see this. So I will choose the following members and surfaces. Maybe I can turn off the results from the linear, from the load case 1. Yeah, and I have to select the surfaces. I will now in the whole cross sections are 21. I can now, or I will define the following stages till the end and go through the input. It remembers the input from the stage before, so here it is activated again, members and surfaces, and I will add the last columns here. I can add it by picking them, or I can also add here the columns numerical. They have here in this example the same number as the construction stage, so I know the number of the columns. For the surfaces, I have to do also the input. If I, it's the same like for the columns, if I select surfaces, it can only apply the surfaces which are not used in the stages before. And I will here finish with the input. I made some short comments here that I know which construction stage or in which construction stage the elements should be used. So and then I'm ready with the definition. In the first stage, maybe I'm not sure if I already did it. Yeah, I did it. I already chose it. Of course, in the first construction stage, I activated additional nodal supports and line supports. And of course, there's only one nodal support at the bottom of the first column. So I can here use also all, or I define, or I select only this single nodal support, and here it's the same for line supports. I selected to use all supports in the first construction stage. Later, I also will show a small example regarding modifying properties during the stages. In this example, the elements are only added, and once they were added, they will not be modified anymore. But then at the end of the webinar, I will show a small example where I have to modify the elements during the construction stage. So this should be the input of the construction stages. After I did the input, I see here also in this drop-down the single construction stages, and I can go through and maybe check graphically if everything was defined correctly. Later there will also the results here available in this menu. Yeah, and now I will define the construction stages on the load side. So we have on the one side the structure, and now on the other side the loads. If I if I've defined the construction stages here, they are automatically generated here in the load cases and combinations. So I can here, for example, edit construction stage, and here I have to choose settings regarding the calculation and also do the import for the used load cases. So first of all, here is the type of the calculation. There is based construction stages analysis based on load combinations. This is yeah, let's say nonlinear calculation. And there's another method, the stages calculation based on result combinations. This is a linear calculation which uses linear superposition and some special algorithms. But this function is also at the moment under development. I guess it will be available soon. Now at the moment we have only the don't have to be only, it is the more specific method, the nonlinear calculation based on load combinations. Yeah, I use here geometrically linear analysis, and I have here also some additional registers where I have to choose here the load cases which should be applied in the construction stage. There's one load case self-rate and one live load. The self-rate I will activate in the first construction stage. According to the load case type, permanent, the program considers this load case as permanent, which means that it is applied to every single following stage, and the program automatically knows or detects if new structural elements are applied in the stages, then also the self-rate of these elements will be applied. So this is the typical load case self-rate with here 1.0 factor 1.0, which is here then applied in the single stages for all new elements which are applied in the constructed stages. And after the construction is finished, and it could be normal used, I can add the live load. Of course, and this is a bit a simplified structure. Of course, in reality, you will probably also have in the last or in the finished state, you have also other live loads and snow and wind, yeah, and loads like this. Here it is a bit simplified. I only have one live load here for the last construction stage, which I will apply here in construction stage 21. And the program knows here that it is non-permanent load, and or that it is a live load, and it is it considers this live load as non-permanent. Yeah, the next register is an overview regarding the combinations, the generated or defined combinations. At the moment, we did not define some combinations, so this is empty at the moment, and you will see here the elements after the combinations are generated. Back to the main register, there's now the topic. We have defined now the loads for the construction stages, and now we have to choose if we want to generate the combinatorics or the combinations, and this is possible if you here use this option to create the combinations according to the combination wizard. So if I want to generate the combinations in the finished state of the structure, I can here check and go to the detailed settings, and here I have to check or I have to be sure that the construction stages are considered. And then after I did this input, the program should automatically generate the load combinations, or first the action combinations and then the load combinations. So I will see, yeah, there are two action combinations, one with only death load and one with considering also the live load. And I see here they are generated for the construction stage 21. And after that, if I go to the load combinations, the load combinations are generated for this construction stage. There are 2 for the design, one with only death load and one also considering the live load. And then the program needs to generate also some auxiliary combinations where it's possible to consider the load case with the used factor for the combinations. The normal stages calculation would be performed with 1.0 permanent load, and here for the combinations it need the construction stages, the construction stages need to be calculated again with the factor 1.05. This is the automatic combination. Of course, there's also the possibility, maybe I forgot to show, here's the settings in the base, the settings for the automatic combination. I used it here according to your code with German Annex. There are also other standards available, but here in the example I use Eurocode with German Annex. Of course, there's also the possibility, if you do not want to use the automatic combinations, you could define combinations manually. I will show this as an alternative. So I can create here a new load combination. Maybe I say it is user-defined. And I can maybe say, it should be a user-defined combination based on the construction stage 10, somewhere in the middle of the building process. But it's just to show how the input works. Then if I have defined it, I have to choose the analysis type. I choose the same as for the construction stages, and then I could here in the special options, this is filled for the automatic combination, it is filled automatically. Here I have to define the special options, which are once the construction stage which should be considered. So this is, for example, construction stage number 10, and I have to choose the previous stage, so the initial state of construction stage 10. This is the construction stage 9 here. Now I'm ready with the definition of the load combinations, and I could check here with OK, and I could start the calculation, maybe first of the combination 2 in the finished for the finished construction. And so this is with live load. There's also construction 1 only for the death load. Here we see normally if you use often without the construction stages, it is possible to calculate the internal forces or the deformations with multi-threading. So it could use more processes here, because the construction stages need the result of the stage before. It is only possible to calculate it step by step. And after this is ready, we can have a look at the results. Maybe we take a result. We take a look at the results without live load. To compare the internal forces with the load case 1, which we saw in the beginning. So now if we consider construction stage, we see that there's another distribution of the internal forces. we have now the field moment in the beginning and the end. It's quite similar. Also the moment above the support. Yeah, and this should be the realistic distribution of the internal forces if we consider that that the deformation in the columns are balanced during the building process, and that the load is not applied in only one step. Yeah. So after we have the internal forces, we can go on with the design. I will here show only as an example the concrete design, only to show the philosophy. It doesn't matter if it is here the concrete design or steel or timber design. I only want to show here how the design in combination with the construction stages works. So I go here to concrete design. I already prepared the input for the concrete design, and I can now calculate the concrete design for the ultimate limit state. I have to start the calculation here. Oh, and yeah, that's a good hint. I forgot something. Yeah, while defining the load combinations and my user-defined load combination, I completely forgot to assign a load case because yeah, it is a user-defined combination, and I of course also have to choose the load case which should be considered, and de facto. This is something I completely forgot, but that's not a problem. Yeah, and now the calculation should be possible. Should only influence this one combination, this one user-defined combination. Yeah, and after the calculation of the internal forces and the concrete design is ready, I will show how the construction stages are considered in the results for the concrete design. I should be ready soon. So, I guess already preparing the results. And yeah, now it should be ready. And then we see here, I prepared it here. I don't want to show it now, especially all the single design checks. I only want to show as an example here the required reinforcement in the same sections which I used for the internal forces. So the required reinforcement at the top and at the bottom side for the section. I see here in the graphics. Regarding the construction stages, I see the results of the construction stages once in the tables for the results. So there's here for the required reinforcement, in the tables for the required reinforcement, I have here the construction stage 10 and the construction stage 21. These are the construction stages where I defined a combination for load combination. Here for construction stage 10 the user-defined combination 23, and for the automatic or for the construction stage 21 the automatically generated combination 2. I also can here select different tables, and the construction stages are also considered in these tables, but this is some special topic regarding the design. I only want to show the principle of considering the construction stages. If I want to take a look at the graphical results of the construction stage, I can here choose the construction stage, and here if concrete design is chosen here, then I see the results for the concrete design for construction stage 21. If I switch, for example, to statistical analysis, I would see the internal forces of this construction stage 21. And here I also can switch to our user-defined combination, or to construction stage 10 with the user-defined combination, and then I see the results of the design for this construction stage 10. If I have a construction stage where I did not apply or generate any combination for, then I see nothing for the concrete design. Then it's empty, of course. Yeah, this only is a short overview how the construction stages are considered in combination with the design. The next step would be the documentation or the printout report. I also only want to give a short overview how the construction stages could be considered at the moment for the documentation. So I have different possibilities. I want to show two. How I could print graphics of the construction stages into the printout report. I already generated a simple printout report without some graphics, only some automatically generated tables for the construction stage. And now I want to print graphics to the printout report. And I want to show the first possibility, which would be to generate different windows and then print different windows at the same time to the printout report. I here generate 4 windows, and I will show them vertically tiled vertical. I only want I have to adapt also the view. I choose the same view here for all the stages, and here I can switch to the construction stages. Yeah, and then prepare the screen for printing. I also could select it by clicking here. So, and I have 4 windows with my defined graphics. I maybe can turn off the axis, or one of the axes. Let's say this one. I forgot it before I defined the windows. And then the graphics are ready for printing them to the printout report. So I can here choose print graphics to printout report. And maybe, yeah. And then I will get this preview of this of the images, and I could here choose. At the moment, there's choose current picture only, but I want to use more windows in one print, so I can choose here more, and maybe I can switch to not as screen view. I can choose here window filling to see the structure a bit larger, and then the graphics should be prepared. And yeah, this would be one possibility how to print the graphics, or how to consider the construction stages for printing the graphics to the printout report. If I use here, okay, the graphics are printed in the printout report. I see it here, and yeah, this is the first possibility. The second possibility would be the multi-print function. Therefore, I have to use it. I have to close these additional windows and go back to only one window. At the moment, there is no special filter related to the multi-print for considering the construction stages. This will release soon. At the moment, I have to create the views manually, so I can here switch between the stages and generate the views. So I will show it. So for example, I showed for the first 3 construction stages. I can here create 3 user-defined views, and then print the or use the multi-print function related to the user-defined views. In the future, there will be some kind of an automatically way for using the created stages directly for printing, but here at the moment I have to do it manually. I will go back to the preview function, and now maybe I can prepare my graphic first before I use the multi-print function. I want to print more than one picture for a site, so I can here say it is not the completely high is used. I use maybe only 30%, and then I maybe can, because it's better from the fitment, I can rotate it 90 degrees. Yeah, and then I have it defined for one picture, and now I can use the multi-print and choose in the next register which views should be used for the multi-print function. And here you in the future will find some additional settings regarding stages where you could use automatically generated views. So here this was the second possibility how printing the construction stages is possible. So this should be the part regarding the documentation. The next part, maybe I can show the printout report. There should be the graphics now there. Yeah, there's one. Oh, yeah, maybe I have to start with a new page here if I want to use them all on one page, and here and above is the combined graphic. I just recognized I forgot to change the language in the printout report to English, but I think it is you see what how the graphics would look like. Doesn't matter which language is used. Yeah, this is this would be the big example. I now want to show some smaller examples or features regarding the construction stages. One feature is, and this is quite new compared to RFEM 5. The possibility to combine the construction stages with other add-ons or other types of analysis. Of other types of analysis. So, for example, I could combine the construction stages analysis with the stability analysis. And here is maybe some practical example. So if I imagine I have here only the first 2 stages of our example, I define them as I did before in the bigger example. Maybe I don't have, got the nodal supports in the first stage and line supports. But this time maybe I do something wrong in the input, and I will choose here for the second stage the column, but I will forget the slab here. So if I want to calculate this construction stage 2, there will be an instability due to this column, which is hinged at the beginning and at the end, and then could freely move if there is no no slab here or no support at the top. So I define the stage without the slab, and I will probably get instability in this construction stage 2. This is here, this example is quite obvious, or the reason for the instability, which I get now in the construction stage 2. The reason is quite obvious, but you will have, or probably will have, some situations in reality where it is not so obvious, and then you could use, or you could combine the construction stages with another analysis here with the structure stability. So I will activate also the structure stability add-on, and then I will open the construction stage 2 again, and then I can use for the construction stage 2 the stability analysis. And here I do not use the normal eigenvalue method. I use some special method which is able to find the eigenshape for the unstable structure. This is this function here. So the stability analysis is able to calculate the mode shape here for this for the situation where the structure is not stable. So I will do the import and calculate again. Of course, the statical analysis is still not possible to calculate, but the stability analysis is able to calculate for the construction stage 2, and we now see here the reason for the instability. So we see it see graphically the reason for the instability. So we see here that the column is able to move freely. So this is one example where it is possible, or where it's also useful, to combine the construction stage analysis with some other add-on or other kind of analysis. Yeah, for example, you could also use dynamic analysis or something like this. It's possible to calculate all add-ons and all add-ons with construction stages. Yeah, this as one small example. There is also another small example. As I said in the beginning, there is also the possibility to modify structural elements in the construction stages. So there's not only the possibility to activate and deactivate elements, there's also the possibility to modify them. Here's an example where I could use this function, or where this function could be helpful. So I have here prepared an example. The construction stages are already defined for different construction stages. And in the last two construction stages, there are in one step applied the steel girders, and in the next one this concrete slab above. And while activating in the last construction stage the concrete blade, the concrete slab, I would also like to change the connection of the steel girders, so they should change in the last construction stage from hinged to rigid, because you have here, you concrete over here these steel girders, and the connection will be rigid. So to do this, I open the last construction stage, and I go to the register members, and then I choose here the 3 members to modify them, or to modify their properties. So here I can choose, I want to modify them, and here I could choose which property I want to modify, and I say here I want to change the hinge at the member start. The program knows, or the add-on knows here the original value of the hinge, and I want to change it from hinged to rigid, so the new value should be no hinge anymore. So, and the same for the hinge at the member end. And then I could calculate. First I see here that something has changed. The hinges are not shown anymore for the last construction stage, and I could start the calculation of the construction stages, and I should see in the last construction stage, for the load which is applied in the last construction stage, I should see a moment above the support here. We change to the wireframe model. Here I see for the new applied load in this construction stage, there will be cast a moment above support for the loads which were applied until construction stage 3. I have here this connection considered as hinged. Yeah. So this maybe also as a small example how to modify properties by construction stages analysis, or in the construction stages analysis. Yeah, this should be all for the examples. Maybe at the end I will summarize some new features compared to RFEM 5, and there we had also the add-on RF stages, and yeah, compared to RFEM 5 we have now some new and quite important features. It is now for example possible to calculate construction stages without adding a new load, so I don't have to add here a load case in every single construction stage. Here it is only considered the permanent load, but I don't have to add loads in the construction stages. It is enough to change the structure side. This was not possible in RFEM 5. It is also now possible to reactivate elements. This could be, for example, useful if you want to simulate renewal of a structure where you remove old parts and add new parts which are at the same place. This was also not possible in RFEM 5. As we saw in the main example, it is possible to use the automatic combinatorics or combinations of RFEM in combination with the construction stages. This was also not possible in RFEM 5. And in the one of the last examples here, in the small example with the stability, we saw that it is possible to combine the construction stages analysis with other add-ons, or rather other types of analyzers. This was also not possible in RFEM 5. Yeah, so this maybe at the end for summarizing the new features. So this is all from my side. Yeah.
Okay, Adrian, you are finished?
Yeah, I'm finished.
Okay, thank you for the presentation. At the end of the webinar, I would like to show you where you can find the recording on our website, dlubal.com. You can find here under News and Events the webinars. Additionally, you will get an email in the next days with a link to that page here. It's today's webinar, and you will find the recording here in the middle and the models to download at the bottom here. Those are the models from the German webinar. Yeah, that's quite the same models. Okay, then I would like to say thank you, Adrian, for the presentation. Thanks to Stefan Frenzel for answering the questions. Yeah, thank you for your attention and have a nice rest of the day. Bye-bye.
Yep, bye.